Following on from my last video, I just want to show you why I'm using iron core for the coils. I use these coils, air coils. I place these inside one at a time. Measured 1.7 volts off one coil, and if I put two together I got 2 volts. If I used the iron core coils, I had 0.7 volts coming out of one coil, but if I put both together I had a reading of 35 volts. So I added some more iron, which you saw in the last video, but this time I placed this setup on my wood burner. So plenty of iron in the wood burner, and I was getting a reading of 215 volts AC. Okay then. So to try and describe what's going on with these coils, I've made these as just a little mock-up. As they stand, this top coil starts off at the bottom, winds up, comes down out here, winds round clockwise. This bottom coil winds round anti-clockwise. And I found that if I joined the two together, I could light the light bulb by connecting to these two. So I tried charging the battery up. Initially I was charging with these coils that had the reading of 35 volts AC coming out of them. This battery was at 3.6 volts. Charged it up for an hour or so with the 35 volts, just these coils on their own, and then I placed them on the wood burner and got the 215 volts and carried charging the battery up. What I did notice, I was charging the battery up. Let's go back to these. Positive on there, negative on there, and obviously to my battery with a diode. But what I found out after charging the battery up is that if I connected these two together on the negative, and then collected the charge or current, you have to excuse my sort of terminology, I haven't been doing this very long, and I collected, that went to my positive, I was charging twice as quick as if I just connected these two and charged off of it that way, if that makes any sense. So the conclusion is, I guess, I'm going to use these two, pulse my magnetic field up and down, draw the power off with these coils. Obviously these need a rebuild. I'm still not certain on how much mass of iron I can get in between these two and how much copper wire I need to draw off the power. But I push these coils over this tube. I mean, this is hydraulic grade steel, hydraulic grade metal, just offcuts from the hydraulic manufacturers down the road. If I did use this, I'd have to cut it in half so that I had north, south, which is what would occur in these coils I mean, I mentioned that it's like a Bedini with no moving parts, whereas Bedini would use a magnet and pass it over this coil to collect the back EMF. This acts as the magnet for this one, and this one acts as the magnet for this one. Well, as I see it anyway. So yes, back to this. Place these coils over this piece of steel. I noticed a magnetic field which was affecting my television set, which is a metre away. I also used this diametrically magnetised magnet and found that I could get it to spin up to 8 inches away and sort of a couple of inches above the top, but I found that it not only spun that way, it would spin that way too. Obviously, by placing these over this steel, the amp draw of these increases, but with tests using these pickup coils, I found that if I draw the power off, the amps drop right down to as if there was no metal in between whatsoever. So that's my findings. I guess the next stage is, like I said, try and design something more specific for these pickup coils. While I'm doing that, I'm going to get a 12 volt to 240 volt inverter because I'm using a 240 power supply, and see how long the device will run off of the battery that I'm charging. Right. Okay, that's it. Thank you very much. Bye then.